Hello, my name is Siddharth, and today we are gonna solve a LeetCode problem. Remove all adjacent duplicates in a string. So let's read the problem first. You are given a string S consisting of lowercase English letters. A duplicate removal consists of choosing two adjacent equal letters and removing them. We repeatedly make duplicate removals on S until we no longer can. Return the final string after all such duplicate removals have been made. It can be proven that the answer is unique. So let me explain you the problem. So the problem is something like this. If we are given this A double B A, okay, we are given something like this A double B A C A. If this is the problem, so the first element will be as it is. The second element, since its previous element is not same as that element, okay, these are not same, so it will get like it only. Okay, then the next element. Now you can see that both of these elements are same. So we are gonna remove both of this. Okay, then A. Now you can see that the both of these elements are same. So we are also removing this. Now we have C and there is no previous element before it. So we will just write C, then A, and the previous element, since it is not A, then it will also get added. So the final answer is C. Okay, so let me show you by another example. Yeah, this one. If we look at this example, okay, description, text. Yeah. If we see that at this example, A, Z, X, X, Z, Y. Okay. There is no previous element before A, so it will be A. Then Z, because the previous element is not Z, it will be like as it is. X, because the previous element is not X, so it will be as it is. Now we have two X, so we will remove both of these. Then Z, because we have two Z here, then again we are gonna remove these. Then Y, because the previous element is not Y. That's why this is our final answer. Okay, so this is what we have to do. So let's talk about approach. How can we do the same? Okay, just imagine we are having a stack here, the stack data structure. Okay, stack. Now let me take this example. Okay, first of all, we are getting A, and since there is no previous element, so I will just have A pushed here. Okay, so the element here is A. So the next element is Z. Since the previous element is not Z, since the previous element is A and it is not Z, so we will again push this Z. Then let's append next element, and that is X. So we will push X because the previous element is not X. Okay, so here it will be X. Then the next element is again X. Now we have a X and the previous element here is also X. Then what is gonna happen? We are gonna remove this, pop this out. This X plus this X will not get added. Then the next element is Z, so we will push Z here. Now since both of these are Z, so we will pop these out. So it will be A only. So what's the next element? The next element is Y. So we'll push Y here. Okay, and we are now at the end of this string. So this is our final answer, AY. Okay, that's what we have to do. So for this, we have to implement a stack first. Okay, so let's try coding the same problem. Okay, so yeah, this is a problem. So let me implement a stack first. Okay, class stack. Then we will assign a constructor. Then for keeping our data, we will just assign a variable and it will be, we can name it anything. I'm saying it this dot items, and we are implementing this stack using an array. Now we will have some methods of the stack. Okay, some of the methods are push, pop, peek. That gives the top, what is in the top of the stack. What this push does, push adds a value to the stack, pop removes a value from the top of the stack. All of these operations are done on the top of the stack. Then we will check if the stack is empty. So we will also implement a method is empty, and one more, print elements of the stack. So we are going to declare all these methods. First method is push, and we will be requiring a element to push. Okay, it will be this dot items dot push. What we will push? The element that we are given. Then the next method is pop, pop, and we do not need any argument because we have to remove one element from the top of the stack, so we do not want any argument for it. So if this dot items is not containing anything, just imagine if this dot items is not containing anything, means this dot items dot length will be 0. If then it is a condition for underflow, so we will return underflow. This is the situation, and if this does not happen, then we are not having an empty stack, so we are gonna pop it out. How? This dot items dot pop. Okay, we are implementing the stack using array, so I'm using array methods. So peek, so in peek what we have to do, we just have to return the top of the stack, so it will be this dot, okay, return. Also we will return this thing which we have popped out, so the user can console log and know which element have I popped out. Okay, so here we will return this dot items, this dot items dot length -1. Okay, it will give us the top of the stack. Now if the stack is empty, then this is gonna give us this is gonna give us true if the stack is empty, and if the stack is not empty, then it is gonna return false. Okay, so what you have to check is if this dot items dot length triple equals to 0, if the length of the stack is 0, then we are gonna return true for it, that is the stack is empty. And if this not happen, then we are gonna return false. And at last we have to print all the elements of the stack. Okay, so the method will be print elements, and yeah. So what we are going to do here, for that I'm going to apply a for loop from 0 till I is less than items, this dot items, this dot items dot length plus plus. And since the JavaScript cannot print in a single line all the answers, so let output equals to an empty string here. Output plus is equals to, we are gonna pop out the elements from the stack and go, no, do not have to, we just have to do this dot items of I. Yeah, this is our approach. I, and last we have to return our output. So we have implemented our whole class of stack. Now we are gonna have a object of stack. Let stack is equals to new stack here. Okay, now we have defined a stack, and we are gonna have one element in it, the first element stack dot push, so that the stack is not empty for our operations. So stack dot push the s of 0. Now we will apply a for loop starting from 1. Let I equals to 1, I is less than s dot length I plus plus. Okay, now what we have to do? We have to do this operation which I have explained to you. Okay, so if s of I, okay, triple equals to stack dot, what was the function? Peak. The peak was the method here. If it is the case, then what we have to do is stack dot pop about that element. Okay, but first of all, we have to check if our stack is empty or not. So we will first check if stack dot is empty, and if our stack is empty, then okay, our stack should not be empty. So I'm gonna apply not here, not empty. So it will, if the stack will be empty, then it is gonna return true, and it will convert it into false. Okay, and if it will convert into false, then this inner if condition will not work at all. So if stack is empty, yeah, this function only. One, no, yeah, this two. So what we have to do here, stack dot pop, and if it is not the case, then what we have to do, stack dot push. We have to push into the stack what s of I. Okay, and also if the stack is empty, then also we have to push into the stack so that it does not becomes empty for the next element s of I. Okay, let me check if the brackets are okay. This is starting here, ending here. No, this is ending here. So where is this ending? This is ending here. Okay, this is ending here. This is ending here. This is ending here. And this is ending here. Okay, so let's try to run the program and see. Also, what we have to return at last. Okay, we have to return what all is available in our stack. Okay, so we have made a method for that too, and that was stack dot, maybe it was print elements. Yeah, print elements. Okay, print elements output should be not here, it should be outside of this for loop. Okay, after the for loop ends, then it should return the output. Let me check the whole program. Just run the code and see if it works. Put is A double B double A double C double A. So it is doing the push but not doing the pop operation here. Let's see what's the problem. Pop. If this dot items dot length equals to 0, return under flow. Otherwise, return this dot items dot pop. To pop out the elements. That's what I'm doing. Peak. Is it correct? It is correct. Maybe return this dot item. This dot items will be -1. Okay, is empty. Where I'm using the pop. It is stack dot pop. Pop out all the elements. So what's the issue with this pop? Let me see. This dot items would length. Cleared it correctly. What's the issue? the length is 0, then let it run flow. Otherwise, return this dot items of pop. This dot items to pop. Okay, yeah, that will happen only. So let's check it's working. Stack dot where I'm pushing here. Stack dot push s of I. Stack dot push s of 0. Stack dot pop s of I. Stack dot push. Okay. Here I have to have a else. If this condition do not work, then this push should be executed. So let's try running this code again and see. Yeah, now it is giving us correct output. Let's check for another test case. Works for this too. It does. So let's try submitting it. And it does get accepted. So that's all for today. See you guys tomorrow.